Hello, I'm Sanket Panda, Product Manager for the Qiskit Function Service. Today I want to talk about how quantum circuit functions and application functions make it easier than ever to get useful results out of quantum computers. So before we talk about circuit functions and application functions, I want to talk a little bit about classical development. So if you've ever developed with a classical computer, these days you're benefiting a lot from abstractions, right? Your method of development is highly abstracted. What I mean by that specifically is that you can focus on developing your software rather than focusing on, lower level characteristics such as assembly language, machine code, the actual hardware you're running on. You focus solely on software and less on hardware. Now, on the other hand, for quantum computing and where it is today, quantum developers haven't had the exact same luxury. So for a quantum developer, this development is still quite low level. What I mean by that specifically is quantum development is still happening at lower levels and representations like circuits, gates, and things like hardware have to be intimately considered in the development of algorithms and application. Today, I'd like to walk through a little bit of what does that quantum software stack look like and how circuit functions and application functions make it easier to develop applications. So let's start at the very bottom. Naturally, this is hardware. This is the actual quantum computer that you can run programs against. This does all your computation. Now, as you can imagine, we have a few layers of software above that we won't talk about today, but this could include things like, control systems or scheduling, so on and so forth. What I do want to start at, though, from a software perspective, is a primitive layer. At the heart of it, I, as a developer, can focus on, passing in inputs and outputs to that. Being able to focus just solely on those aspects mean that I don't have to, translate to whatever lower level of hardware language that the quantum computer runs on. Now, given that today's quantum computers are noisy and error prone, you also have some notion somewhere in here of error handling. This can come in a couple of different flavors, error correction, error suppression, error mitigation, and happens, all across the stack. But when we talk about getting our circuits, our observables ready for actual computation, we have some notion of transpilation. All this means is, translating this virtual representation or abstract representation of these circuits and observables to something that is, interpretable by the lower levels of our software stack and our hardware. Now, here's where you can probably start telling that to develop on a quantum system, you need to have intimate knowledge of quantum physics, hardware characteristics, selecting what great transpilation passes you might use. That's not necessarily a skill set that every developer has, so we're introducing circuit functions as a concept here, as something that I can focus, change color, on just my inputs, the quantum circuit, and observables. So, observables, there we go. And get at the end of it, mitigated expectation values and counts. With this, a lovely thing is that researchers can focus specifically on creating great representations of their workloads in that quantum circuit and observable thing, in that form, rather than worrying about, transpilation, how to get the maximum out of hardware characteristics, so on and so forth. Now that's one layer of abstraction, this circuit function. I want to also talk about one more layer of abstraction that we have for application functions. Now, as you can imagine, if I am a computational chemist, for example, my goal is to be able to have this, simulate a molecule, right? I want to be able to pass in things like a domain-specific input like molecular definition and get out something like, energies as a domain-specific output. I can take that information and, use it for higher levels of abstraction such as catalysis or reaction path analysis, so on and so forth, right? But this notion of mapping my classical information to quantum, circuits and observables is also deep research today. To see how IBM and its partners are working on creating these layers of abstraction, I encourage you to check out some of the links in the description below to find out about circuit functions and application functions. Thank you so much.